Okay, so one of the best methods that you can use to solve a lot of algebra problems is using trial and error. Now, a lot of people don't think of trial and error as a kind of primary method or something that they should actually, do to solve a math problem, but in fact, it is a very important method and something that you definitely want to kind of keep in the back of your mind when you are looking at a problem, especially if you don't know how to directly solve that problem. Well, let me show you a quick example of trial and error just in case you don't know what it means. It effectively means just trying different values until you get the right answer. So let's take a look at this equation right here. 2x, let me write this out a little better. 2x is equal to 10. All right, now this is a simple algebra problem, algebra equation. Now, obviously, if you know algebra, you can solve it directly. But let's suppose you didn't know algebra. How can we determine the right answer? Well, 2x means 2 times some number x, okay? Well, we could just start testing values, right? So I could plug in a 1. So 2 times 1, that is 2. So is 2 equal to 10? No, it's not. So 1 is not the solution. So we could just continue to test values and see the results. Well, eventually we're going to test 5, right? So 2 times 5 is 10, and 10 is equal to 10. Well, 5 is the solution because, through trial and error, we figured it out. So that is the trial and error method, in kind of in a nutshell. And we can use this method to figure this quadratic inequality out. And that's the problem that we're going to be taking a look at in this video. Now, if you are taking algebra, you definitely need to understand the various methods and techniques to solve this problem. Now, I'm going to show you those techniques, but let's suppose you forgot all that, or if you didn't even know any of these techniques, you could still use trial and error to figure out the right answer. So, what is this saying here? Well, we're looking for values of x that are going to, so let's, x again represents a number, right? So, we're looking for some values of x such that when we plug in and we replace these x's here and we do all the number crunching, this entire value has to end up as what? Well, if it's less than or equal to 0, only numbers that are less than 0, numbers over here, are negative, right? So this entire thing has to end up as a negative value to make this a true statement, right? Because the negative values are less than 0. Now, if we end up with an x value that is actually produces a 0 for this entire expression, well, this is less than or equal to 0, so that is part of the solution as well. So again, even if you don't know the actual algebraic methods to solve this problem, of course, I'm going to show you these, you could just start trying different numbers. So if you think you can figure this out, and even if you don't think you can figure this out, you certainly can try numbers. Well, go ahead and put your answer into the comment section. I'll show you the correct answer in just 1 second. Then, of course, we'll look at different techniques that we can use to solve this problem, to include trial and error. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, well, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, now before I show you the answer, what is the answer? What is the solution to this problem? What is it? Okay, what's the form of the answer? Well, it's going to be numbers or values of x such that when we replace these x with these numbers, this statement is true. So we're going to be talking about a range of numbers. There's just not one value of x that makes this statement true. So we're talking about a set or an interval of numbers. And let's go and take a look at the right answer right now. Here it is. It's any one of these. And now, if you don't understand these solutions, these are all equivalent. Basically, what this is saying is the following, okay? All numbers that, I can write this a little bit better than that. Let me write this like this, -1, greater than or equal to x, less than or equal to 5. Okay, so you have 4 ways you can express the answer. These are all equivalent, just different notation. But effectively, all numbers that are greater than or equal to -1 and less than or equal to 5. So within this range of numbers on a number line, to include -1 and 5, all these numbers are solutions to this quadratic inequality. Okay, so again, through trial and error, you could have tested a whole bunch of numbers and said if you were testing numbers in between this range, you would have seen or determined that in fact those numbers made that quadratic inequality true. Okay, now if you got this right using some technique, even trial and error, that is fantastic. And I have to give you a nice little happy face and A plus, a 100%, and multiple stars so you can tell your friends and family that indeed you know how to solve quadratic inequalities. Now, again, if you are an algebra student, you definitely need to know the primary techniques to solve inequalities. This is a big deal and it can get much more sophisticated, especially when you're dealing with something called rational inequalities, but that's for another kind of video. Again, what we want to keep in mind here, excuse me, is this concept of trial and error. All right, so let's go and get into it right now. So trial and error, right? So we're just testing values. So it now the thing about trial and error is the following. It's not necessarily, although it's an effective method, okay, it may not be the most efficient method, right? So there is a big difference there, right? So in other words, you can test a whole bunch of values, hundreds and hundreds of values. Eventually, you're going to get pretty close to the correct answer. So trial and error may not be your go-to technique, okay, but it's one that you certainly can use. So to figure this thing out using trial and error, you would just simply start replacing these x's with various values. Okay, so you can start maybe with -10, you could go with -5, you could start with 0, 1, 8, doesn't make a difference. You want to basically span the number line and just test various values. Now, a quick suggestion here when you are using a trial and error method, or if you're just testing random values, use easy numbers like 0, right? So 0 is a super easy number to check. So is 1 and maybe -1 as well. So when you are using a trial and error method, you want to use nice values and then you want to kind of spread out as well. So always think of like the number line right here. You have 0, that's easy to check. 1 is easy to check, -1, and then kind of span out on both sides of this number line, maybe kind of get far away. You just kind of have to be a little bit random about it, but use easy values. Now, if you did that, you would have kind of determined, hopefully, that you were getting values that were making this true between -1 and 5. In other words, when you're testing numbers in this span, and if you weren't testing numbers in that span, well, that just indicates to me that you weren't using or you weren't running enough trials, right? So you have to run a good amount of trials again in order to, be successful with the trial and error method, unless you get lucky. But that is, effectively what the trial and error method is and how to use it. Now, I'm not going to run through all the number crunching here. You can kind of do this on your own because I want to get to these algebraic techniques, and then I will show you a little bit of how trial and error is actually an important part of the kind of procedure to solve a quadratic inequality or inequality problems in general. So let's go ahead and get into this right now. So if you were facing this problem, okay, right here on an algebra exam or whatnot, your teacher is not necessarily going to want to see you use trial and error. They're going to want to see you using another method. So what we have here is a quadratic expression. Now, when you study algebra, you study a lot of things about quadratic functions. Okay, that's what this is right here. Namely, you need to know how to solve them. So if I set this thing equal to 0, you need to know how to solve a quadratic equation. And if I set this thing equal to y, like this, y is equal to all of this, you need to know how to graph quadratic functions. Okay, now the graph of a quadratic function is some sort of U-shaped graph called a parabola. So these are things that you need to know in order to figure out this problem. But let's go and get into it right now. So we have our quadratic functions, and the first thing we want to do is find something called our critical points. So we're going to forget the inequality for a second, and we're going to put in an equal sign. So now we have a quadratic equation. So we're going to solve this quadratic equation, and luckily for us, This quadratic trinomial is easily factored into x plus 1 times x minus 5. Now, if you don't know how to factor, you're going to have a tough time passing algebra. This is an absolutely critical skill. But the reason why we like to set quadratic equations or any polynomial equation equal to 0 is because if we can factor, we can use something called the zero product property. Okay, zero product property, which means the following. Okay, I have this thing being multiplied by this thing, and the answer is 0. So if one thing times another thing is 0, if I came up to you on the street and said, hey, I have two numbers. When I multiply these numbers together, the answer is 0. Can you tell me anything about these numbers? Well, you would say, well, one of these numbers must be 0 if the answer is 0, or both. And that's basically the zero product property. So effectively, we could take these factors and set them equal to 0 because one or both have to be 0 in order for this to be true. Okay, so we have x plus 1 is equal to 0 and x minus 5 is equal to 0. So when we solve, we're going to get x, and we solve both of these little linear equations. We have x is equal to -1 and x is equal to 5. Remember, when it comes to quadratic equations, there are always two solutions. Okay, now if you need to review quadratic equations or any of this stuff, and you definitely have to learn it, full on. I'm going to refer you to my Algebra 1 or Algebra 2 course. You'll find links to those in the description of this video. Okay, so what does this mean? Well, these are our critical points. X is equal to -1 and x is equal to 5. And these points here, they should look familiar to you, right? -1 and 5. You're like, hey, isn't that part of the solution right here? All the numbers between -1 and 5 to include -1 and 5? Yes, indeed, that is a part of the solution. Okay, so again, these are critical values or critical points. So this is how they're kind of described when you learn how to solve inequalities. Now, let's go ahead and take this a step further. So let's get back to our problem. And now let's think of this. We'll get back to what these points mean here in a second, okay? -1 and -5, because we're going to need these critical points when we think of a graph. Okay, so now we want to think of the graph of this quadratic function. So we're going to just throw a y in front of it. So this would be the graph or the equation of a quadratic equation. Okay, so y equals x squared minus 4x. We can graph this on the xy axis. Now, another great illustration of trial and error, it's really not trial and error, but it's just more getting points. Even if you didn't know how to graph a parabola, okay, you could just start testing various values of x. So let's say -10, 8, 0, 1, 5, etc. And you could plug in various values of x and get the respective values of y's. These are actual points that you can plot on the xy plane and actually kind of connect the dots. So that's kind of, somewhat like trial and error. Again, a very, very effective technique with a lot of things in algebra, but hopefully you know how to graph this parabola. So if you notice here, our x squared is the coefficient, the number in front of this is a positive 1x squared. So this is going to be an upward parabola, and it's going to go through these critical points, which are the real number solutions, -1 and 5. Okay, so let's go ahead and graph this. So this is the graph of that parabola, -1 and 5. Okay, so we have this quadratic inequality. Okay, let me erase this right here. Okay, we have the graph of it. And what is this saying? Well, we're looking for values of x such that when we place in these values of x, the entire result is going to be negative. So what values of x produce a negative result? Well, and the negative result is going to be y. So these values right here between -1 and 5, because we need to look at the y-axis. Okay, so when we plug in these values for x, like x is equal to 0, or x is equal to -1, or x is equal to 4, the resulting y values, these are the x values, okay? The resulting y values are going to be on the y-axis. So in other words, right here, let's take this point right here, for example. So when we plug in 0, we're going to get this y right here, okay? So this is the xy coordinate for that particular point. So the values of x that produce a negative result or a negative y, right? So back over here, if I put a y in front of it, what values of x, such that when I plug these values here, are going to produce a negative y, which of course, negative y is what we're looking for, right? These values have to be less than or equal to 0. So what y values, where is y less than or equal to 0? So you have to look at the y-axis, not the x-axis. So these, or this part, let me kind of draw that a little bit better. Okay, this part of the y-axis is positive. Okay, this part is negative. So here's 0, and then we have positive 1, positive 2, positive 3. Down here we have negative 1, negative 2, etc., etc. So where is y negative? Y is negative this way. So the graph is underneath the x-axis, or negative between this range right here, negative 1 and 5. So graphically, you could determine the result here, okay, of this quadratic inequality. Where is this less than or equal to 0? It's less than or equal to 0, okay? The y values are less than or equal to 0 between negative 1 and 5 to include negative 1 and 5, these endpoints, because that makes this 0, okay? All right, so hopefully that makes sense. So when you have to graph, or when you can graph functions, it's a very effective technique to solve a lot of problems, to solve equations and inequalities, particularly quadratic inequalities. Okay, so that is one algebraic technique. I'll show you another algebraic technique, but let's go ahead and get back to this graph again, right? Because a lot of people get confused with this. So again, right here, the x values are the input values, okay? The y values are the output values, and this has to deal with functions, okay? So right here, for example, this is an xy point. So this value of x, whatever, whatever it might be, this particular value right here is going to produce a negative y, okay? Because that is the point on the graph. This point over here, for example, okay, this is an xy point. So this value of x right here is going to produce a positive y, and that's not what we're looking for. So you have to get, comfortable studying graphs. Graphs are a huge part of mathematics and algebra. All right, so I'm going to show you another technique that we can use to solve this problem, and it's kind of related to the trial and error method, but let's go ahead and review how to express the answer. Okay, so again, as I kind of indicated in the beginning of this video, the solution is all values of x that are less than or equal to 5 right here, and greater than or equal to negative 1. But when you are studying inequalities, you need to know how to express these ranges of numbers, these intervals, which they're called. Okay, and these are various techniques. So all these are correct. So you can have a closed circle, a negative 1 to 5, or you can have this bracket, not open, or parentheses like this, which mean open circle. So this is a whole big topic in and of itself. And then this particular notation right here is called interval notation. This is kind of used in a little bit more advanced math. Again, if you need help with any of this stuff, check out my full algebra courses. If you're at a more advanced level of mathematics, you may want to check out my pre-calculus course. I really get into this type of notation, and this is effectively what you're going to be using at much more, higher levels of math like pre-calculus and calculus. Okay, so hopefully this all makes sense, but now let's go ahead and take the next step, which of course is having you quickly subscribe to my YouTube channel before I show you one more algebraic technique to solve this problem. So, if you're having a tough time in math, one of the best things you can do is raise your hand, okay? If you're kind of shy and you're like, you don't like to raise your hand, well, maybe you can kind of, whisper over to your teacher or do whatever, but you got to get help, okay? The worst thing you could do is just sit there and being frustrated. You're not going to, improve unless you, ask for help, okay? Now, oftentimes, what a lot of people do is they try to help themselves, and that is admirable. I mean, you certainly want to, try to learn as much as you possibly can on your own, but just keep in mind, if you have a great mentor or tutor or a teacher, they can speed up that process, okay? So don't be shy to ask for help. And the key to learning math, or key to learning from someone else, is you got to ask this question: hey, do I understand how this person is teaching math to me. So, if you've had teachers that were like totally confusing to you, there's nothing wrong with that teacher per se or you per se. You have to try to find, connect with the teacher that you can understand. And that's difficult, especially if you are in a class and you can't change classes to another teacher. So, with all that being said, if you like and you understand my, teaching style, I have a ton of content on my YouTube channel that you can use, not as a full replacement for instruction, but you can certainly use it as like tutorials. But if you truly want to learn math from me, check out all my main math courses. You'll find links to them all in the description of this video. And the best way to support my work is just to hit that subscribe button. And if you're going to do that, you might as well hit that notification bell as well. Okay, so let's go and take a look at another way we can approach this problem. And effectively, we're going to do the same thing. We need to find the critical points. So we're going to replace this inequality symbol temporarily with an equation side, and we're going to solve the quadratic equation, which we already did that work, right? So we know that the solution to this quadratic equation is x is equal to -1 and x is equal to 5. Okay, so again, we need to find the critical points. All right, now what do we do with these solutions? Now, previously, we looked at the graph, right? And we were able to determine the solution set through, graphically, visually. But what we can do is use kind of like trial and error. So this is the way you use this particular technique. Okay, so once you have your critical points, which are the solutions to the equation, you're going to draw like a little number line here. And this is the way this works with quadratic inequalities. You're going to have regions. You're going to have true regions and false regions. So we're going to split up this little regions here by -1 and 5. So all the numbers in between -1 and 5, all the numbers that are greater than 5, and all the numbers that are less than -1. Now, we're going to determine which regions are true and which regions are false. Now you can see here I already have the answer. When you plug in these values right here into our quadratic inequality, you're going to get false statements. In other words, these numbers are not going to be less than or equal to 0. Okay? If you plug in values over here, you're going to get false statements. If you plug in values over here, you're going to get true statements. Now, instead of just doing full-on trial and error, and not having any kind of sense of where to start, when you have your critical points, this is, basically splits us up into 3 possible regions. Now, we don't know the correct answer when you start doing this, right? This can end up being false, this can be true, this can be true. So you don't know that. You have to kind of start, by testing numbers. So let's go ahead and take a look at a couple quick tests that hopefully you can do. So let's suppose we'll test x is equal to -2. Now remember, going back to our region here, we're testing a value over on this side to the left of -1. So we'll test -2. So we plug in -2 into our quadratic inequality, and we do all the number crunching. I kind of already did this for you. We're going to get a 7. Now 7 is not less than or equal to 0. That is a false statement. So we don't have to test anymore in that region. You see, this is not full-on trial and error. We are testing. We are kind of using trial and error. But once you've tested one point and you determine this region is false, that's all you have to do. Okay, you don't have to continue to test again in that region. All right, so now we'll test another point in that middle region. We'll test x is equal to 0, and we plug in 0 for x. We do all the number crunching. We get all this equal to -5. And is -5 less than or equal to 0? Indeed it is. That is true. So 0, okay, which of course is in this region. So this is true. And so all we have to do is one more test in this region right there. So we'll pick a value greater than 5, so maybe something like 6. So we'll plug in 6, and when we do all that number crunching, we get 7 again. And 7 is definitely not less than or equal to 0, so that is false. Okay, so again, this is another kind of way you can approach this problem. So different techniques you can use in algebra to solve inequalities, and this becomes much more challenging, especially when you start studying rational inequalities, problems like this, x plus 1 over 2x is less than 5. This looks rather simple, but in fact, these type of problems are pretty involved, and this is stuff that you learn at a higher level of math. And if you need help with, either quadratic inequalities You can check out my Algebra 1 course, Algebra 2 course, or Pre-Calculus course. If you're studying rational inequalities, you got to check out my Pre-Calculus course. Okay, so hopefully this was an interesting little video. And I know it covered a lot of information, but I wanted to stress the importance of trial and error, okay? Because, even if you don't know how to do something, if you know how to test values, you can, oftentimes you can get pretty far with this technique. And that's really important for those of you out there that are students, okay? Because you simply can't afford not to try to answer a question to the best of your ability, right? You can always just try some numbers and see what happens. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.